Hi guys, so today we're going to be going over chapter 14, which is on soil erosion and control. The first section is just going to be a little overview on the types of erosion and why it's important. So first, land degradation is a reduction in the capacity of land to provide ecosystem goods and perform functions and services that support society and nature. So it basically means that the land is no longer able to perform ecological functions as it used to, whether it be due to human activity or natural erosion. Almost half of the world's vegetated land has been degraded over the last century, and much of this is due to physical soil degradation. And here's just a little map for you guys to see where most of the degraded soils are. So there's a few types of physical degradation, and they are water erosion, wind, tillage, surface sealing, and compaction. And we'll touch on these categories more in depth later. So there's two main types of erosion, geological erosion and accelerated. So geological is basically soil erosion that takes place naturally without the influence of human activities, which happens slowly, and new soil is formed fast enough to keep up with the erosion. Whereas accelerated erosion is the human disturbance of soil or natural vegetation, which it can include overgrazing livestock, deforestation, plowing, and construction, and this can actually be 10 to 1,000 times as destructive as geological erosion. And so you might be asking why all of this is important, and it's because land degradation means that there's going to be plant community damage and soil degradation. This accelerates ecosystem damage and human poverty. People who rely on the land for a source of income can struggle as the land degrades. There was actually a really good quote at the end of the chapter that says, "Poor land makes poor people, and poor people make poor land." Continuing on from the last section, here are more impacts of soil degradation. So there are on-site damages. So those are when fertile soils are eroded away, leaving the less fertile soil. And wind and water erosion can remove the organic matter, minerals, and nutrients from the soil. It can also displace plants and spread plant disease, and in general, it deteriorates the soil structure. And then, of course, there are off-site damages, which means that erosion carries sediment and a lot of issues to other places, resulting in off-site damages, especially water pollution. So that can be through eutrophication and other waste runoff, but it can also be how sediment flows into the water, making it turbid, resulting in less light penetration, which is bad for the submerged aquatic vegetation. Sometimes when the streams carry sediment, it can get deposited into one area, impacting the area and reducing the flow of water, which is how the accumulation of sediments results in mudflats and damages to reservoirs. With wind erosion, wind-blown dust can result in the inhalation of particulate matter, which is really bad for air quality, and in general, once again, it reduces the soil productivity. The next section is going to be more about water erosion, and so the steps of water erosion are detachment of soil particles from the soil mass, transportation of particles downhill, and deposition of transported particles at a lower elevation. There are two main modes of transportation for water erosion, which is through running water and raindrops. Running water can be a little self-explanatory because the water runs over the soil and the sediment, and it picks up pieces and it transports it to other places. But for raindrops, so they fall until they reach a terminal velocity, which produces a really big force when hitting the soil, and this detaches the soil, destroys its granulation, and splashes. And most erosion is actually initiated by raindrops rather than running water. And there's a few types of water erosion. There's sheet, rill, and gully. So sheet is basically when splashed soil is removed uniformly except where pebbles intercept the rain. Rill erosion is small flow channels created by runoff. And then there's also interrill, which is sheet erosion in between the rills. And then gully erosion is large flow channels created by runoff. And then the last step of water erosion is deposition. And for the delivery ratio, so that's basically the amount of soil delivered over the amount eroded. And the delivery ratio in smaller watersheds are going to be greater than delivery ratios in large watersheds. The next section is going to be about predicting water erosion. Some of the models are going to be the Water Erosion Prediction Project and the Soil and Water Assessment Tool. These are computer models, but they're often inaccurate. So the standard is actually the Universal Soil Loss Equation, which predicts the average soil loss in a year. And then there's also the Revised Universal Soil Loss Equation, which is basically just a computer version of the Universal Soil Loss Equation, and it uses the same principles, but it's continuously modified to be more accurate. And you can actually go ahead and look at the equation right above, because our next section is going to be factors affecting rill and inter-rill erosion. So we're going to be taking a look into all of those variables from the Universal Soil Loss Equation. First is rainfall erosivity, which is the main factor for rill and inter-rill erosivity, and that considers annual rainfall, intensity, and seasonal distribution, and it calculates an index of kinetic energy from each storm, and so the average index over many years is going to equal the factor R. After that is soil erodibility, which is specific to each kind of soil, and it's going to be the soil lost per unit of erosive energy in rainfall. And some of the factors that it considers in the soil are the infiltration capacity and the structural stability. After that is the topographic factor, which is the length and steepness of the slope, and the factor is going to be the soil loss over the standard plot slope and length. After that is cover and management, and that basically means that denser cover equals less erosion. And then there are support practices, which include erosion control through managing the vegetative cover, residues, and tillage. Those last two can actually fall under the best management practices, which are some tactics that people can use to reduce the soil erosion and take care of the land. And some of those tactics can include things like strip cropping, contour strip cropping, and terraces. And here's a photo example of what a terrace might look like. And falling under the best management practices is conservation tillage. So tillage is traditionally used to kill weeds and plant seeds in looser soils, but it can result in the loss of nutrients and organic matter. But conservation tillage can allow for the benefits of tillage without losing the soil productivity. There are a few methods of conservation tillage. So first is going to be chisel plowing, which stirs the soil but only a few centimeters deep. There's stubble mulching, ridge tillage, which is planting on top of permanently raised ridges. And then there's also a no-till method where almost all of the soil surface remains. And that's really good for dry climates because it preserves as much of the soil moisture as possible. And then there's more modern practices like vertical or turbo tillage, which is basically really fast tillage and it stirs, but it does not invert the soil. So the effect that conservation tillage has on erosion control is that it results in less water runoff and it reduces the loss of sediment nutrients. And no-till actually helps the soil the most because it increases the organic matter and soil organisms. Also falling under best management practices are vegetative barriers, which are narrow rows of vegetation, and they're mostly tropical grasses, but they slow runoff, and they also filter out sediments. Next is the control of gully erosion and mass wasting. So out of all three types of erosion, gullies are usually the most harmful just because they are bigger, but smaller gullies can actually be filled. And the bigger gullies, they use check dams, so it can stop the growing of the gullies. And if enough sediment forms in those dams, they can actually be turned into permanent terraces. And now for mass wasting. Mass wasting is the downhill movement of large soil masses. The first type of mass wasting is soil creep, which is where upper layers of soil move down slowly. And then there's mud flows, which is the partial liquefaction of the soil, and there's a moderately rapid flow. And lastly is landslide, which is shear failure, which causes rapid downhill movement of the soil mass, and it also is usually in wet conditions. Next is the control of erosion on range and forest land. So some of the rangeland problems can include overgrazing, cattle trails, and wind erosion. And there are generally less issues in forest lands, especially healthy, undisturbed forests. but some of the issues that can occur are watersheds, logging, trampling on trails and off trails, and sometimes gullies can form because of that. And then there's also water dripping from the leaves that causes splash erosion worse than even rain, but mostly the forest floor protects the soil. Touching more on the causes of erosion in forest land, first there are logging roads, which are paths for trucks, and then there are skid trails, which are the paths where logs are dragged, and there are yarding areas, which are places where the logs are collected. To help reducing the eroded soil in these areas, we can start with intensity of harvest. So basically there are a couple of tactics like selective harvesting and shelter wood, where they harvest only the oldest trees or a portion of trees. And then there is the actual tree removal itself. So currently they use something called skidders to drag the logs to wherever they need to go whenever they're transported, but those can really disrupt the soil. A better alternative to that would be cable lifting or airlifting. It is significantly more expensive, but it also reduces soil erosion drastically. And then, of course, there's design and management of the trails. So by doing things like creating buffer strips and water bars, we can control the water flow. And the next section is erosion and sediment control on construction sites. So there are two main goals in controlling erosion on construction sites, which is to avoid on-site damage and whatever is eroded to maintain that sediment on site. So there are a few principles of erosion control, and so basically you want to excavate during low rainfall periods to reduce runoff, divide the project into phases so that smaller areas must be cleared at a time, cover the disturbed soils, control runoff flow, and trap the sediment before releasing runoff. So looking at soil cover, you're going to want to keep the disturbed soil covered with mulch or erosion mats. And then for steeper areas, there are things called hydroseeders. And then when it comes to controlling runoff, so there's going to be hard armor, soft armor, and bioengineering. Hard armor can consist of riprap, which is large rocks used to protect the soil from runoff. There's gabions, I'm not sure how to say that, I think it's gabions, but mesh containers filled with hand-sized stones. And then there's geotextile, which is tough, non-woven filter cloth that separates the stones and the soil. And then there's the soft armor, which can include grass sod and erosion blankets. These are more aesthetically pleasing and can lead to more natural flowing waterways, and it's also generally better for smaller channels. And then for bioengineering, that's using vegetation and other natural materials to protect channels from high velocity water. So that can include the use of brush mattresses and the live stake technique. And then last but not least, there's trapping sediment, which is filtering the sediment out of runoff using a cloth or plant fiber. And on larger construction sites, protected slopes and channels lead the sediment into sediment ponds, which ensures that all of the sediment does not get into the runoff and pollute other waterways. Next, we're going to look at wind erosion. So wind erosion are strong winds blowing across soils, and it affects sandy and silty soils the most, but it can affect any soil. A good example of this is sand dunes. So they're the worst in dry areas, but it can work in conjunction with water erosion as well. So overgrazing and tillage can result in drier soils, which means that wind erosion is probably going to affect that area even worse. With wind erosion, the methods of transportation are going to be saltation, soil creep, and suspension. So saltation is basically when the particles move with short bounces on the ground, and that's the most common transportation in wind erosion. Soil creep is the rolling and sliding of larger particles, and suspension is the particles moving parallel to the ground and up through the air. Some of the factors that affect wind erosion are going to be the wind velocity and turbulence. So obviously, however fast the wind is going, however strong the wind is blowing, the wind erosion is going to be stronger. And then the surface roughness. So the rougher the surface is, the less severe the erosion will be. And then we also have to consider the soil properties themselves. So that can include the stability of soil clods and aggregates, the stability of the crust, bulk density, and the size of soil fractions. And then there's also vegetation, which we know that vegetation can be used as a barrier to erosion. So more vegetation reduces the wind erosion. Next is predicting and controlling wind erosion. So once again, there are a few formulas for predicting it. The first one is going to be the wind erosion prediction equation. This equation can consider things like soil erodibility, soil ridge roughness, vegetative cover, climactic factor, and the width of field. And then there's also the revised wind erosion equation, which is a computer model of the wind erosion prediction equation. So the revised wind erosion equation is kind of like what the revised universal soil loss equation is to the universal soil loss equation. It's pretty much the same thing. It's just a computer model, and it's being continuously updated to be more accurate. And then after that, there's also the wind erosion prediction system, which is the wind version of the wind erosion prediction project. So to control wind erosion, we can mess with a few factors like soil moisture. So we know that more dry soils are heavily affected by wind erosion. So by upping the soil moisture, it will control the erosion. And then there's soil cover. So more cover means less erosion. There's conservation tillage. And then there's also barriers and windbreaks, which reduces the wind and it traps drifting soil and sediments. So that can include tree shelter belts and rows of shrubbery, grasses, and grains. Next, we're going to talk about tillage erosion. So we already went over conservation tillage, but we're going to talk about the effects of traditional tillage. So tillage, as we know, loosens and moves the soil. And so the net movement is always downwards. So topsoil accumulates in the valleys. And so to predict or quantify whatever tillage erosion there will be, we use the tillage erosion risk indicator, which is basically the erosivity of the tillage and the erodibility of the land. And that equals the annual rate of soil movement. And then our last section that we will go over is land capability and soil conservation. So there are actually different classes of land capability, which are basically the degree of limitation on land use. So class 1 is going to be the least limited, and class 8 is going to be the most limited. And then there are different types of limitation. So you might say 1E, so that means that it's the least limited, but the limitation is the risk of erosion. And then there's W for wetness, drainage, or flooding. S is root zone limitations, which include acidity, density, and shallowness. And then C is climactic limitations. And overall, for conservation management, the goal is to protect soil from erosion and enhance soil health, and we can do that through sustainable farming systems. And that concludes chapter 14. Thank you for listening, and I hope you learned something.